That's smart. I'll do that. Thank you.
Okay, sure. Okay, guys, so like I said, test is going to be on Wednesday instead of Monday. So if you printed out the course assignment sheet, you will have to go back and reprint it once I send a message saying that I've updated it, okay? All of the chapter review, the answers are out, so you guys can go check all of your work, okay? It's, you know, obviously however you work it, just make sure you do it so that you're learning. And then bring your chapter review homework on Monday and I'll check it, okay? Check out the videos that I sent. They are really, really good. Some of them teach it a little differently than I do, which is good because everybody's brain works a little different. Something will click with somebody that didn't click with me, you know, with what I was teaching. So check that out. Okay, so we are going to go through a brief review and then we're going to run through all of our notations and configurations because there's a lot of words on, gosh, there's like all these notations. How do I know which one to do? Okay, principal quantum number. Somebody remind me, what is principal quantum number? What's the letter that it's represented by?
N.
N. It's represented by an N.
Oh, it's
right?
what energy level the electrons are.
Yes, it's energy levels, right? Yep. Energy levels electrons are found in. And what is the equation to find how many electrons are in a particular principal energy level?
So we went over this last class.
Mm-hmm.
It's 2n squared?
Yes, 2n squared.
I just
2n squared. So if I say how many electrons can fit in energy level 3, what would you say? 18. Yeah, because you just fill in number 3 right there as the principal energy level. 3 squared is 9, 9 times 2 is 18. Who can tell me what the Heisenberg uncertainty principle is? We went through that.
You can't be certain of it's the location of the atom and the momentum?
Location and momentum of the electrons.
Oh, yeah.
Yep. You cannot be certain of the location and momentum.
I'm so close. I almost said electron too, and then I was like, no, it's atom.
Right, so you can't be certain, but you can have basically almost like a probability plot, okay? That's why we have principal quantum numbers and we have subshells, because it's kind of like a probability plot of where electrons will be found. So it's basically our model, what we've come up with so far. We have not discussed the name of this, but I know we discussed the principle of it. Can you guys tell me what the off-ball model is? If anyone took notes.
No, I don't remember.
Oh. Is that the one where they have to be opposite spins?
No.
Oh, that's the Pauli solution.
So electrons fill the lowest possible energy sublevel first. Right? So it's kind of like, that's why we have the 1s and then the 2s and then the 2p, then the 3s, right? So because they're saying that basically you follow that diagonal because you are filling the lowest subshells first, okay? You're not going to put any electrons all of a sudden in energy level 4 when you've not filled up 1, 2, and 3, okay? And the S, P, and D for those energy levels, okay? So you're going to start on the lowest possible energy sublevel first, and you're going to fill it, okay? Before you move on to the next one. Okay. The next one is the Pauli exclusion principle. There's many principal parts to this, but the one that it pertains to this chapter that they brought up, what did they say? I think we brought this up too.
Opposite
electrons in an orbital have opposite spins. And if you think about it, electrons both have a negative charge, right? All electrons do. So if you put like two negative sides of a magnet together, they're going to repel. So if you think about it that way, these negative charges are constantly in an opposite spin, kind of away from each other, okay? So they're constantly spinning in opposite directions. And then do you guys remember what Hund's rule is? You read about it, we did not discuss it yet.
So
Huh?
electrons fill empty orbitals first before pairing.
Yes, exactly. Yes, yes, yes. Wait, tell me exactly what you said then.
Electrons fill empty orbitals first before pairing.
Yes, you'll have one in each orbital first before pairing. Yes. Electrons will, what's the best way to say this? Because they don't fill it, I guess that's the word that's kind of tripping me up. They will,
It's just like the unpaired ones, right?
so each electron will receive one, or each orbital. Let me write it this way. Each orbital will receive one electron with the same spin. Before pairing electrons. Okay? Each orbital will receive one electron with the same spin before pairing electrons. Some people call this the bus seat rule. It's because if you walk on a bus and you don't know anybody and there's an open seat, chances are you're gonna sit in that seat before you go sit by a stranger. So you're gonna put one in every seat before you start doubling up and pairing up. Okay? Okay. So now let's do a quick review on our subshells or sublevels. Okay? S, P, D, and F. So S, what is the shape?
Singular sphere.
Singular sphere. Okay. How many electrons can it hold?
Two.
2 electrons. All orbitals can hold 2 electrons, right? And you already said how many orbitals it had, right? You said singular, so it has 1 orbital. Okay. P, what's the shape?
Peanut.
Peanut.
Do the next
I'm
one.
going to come over here first. How many orbitals does P have?
It has
3.
3 orbitals. And how many electrons can it hold?
4.
No, 6, because every
Oh,
orbital
right,
can
because
hold.
it's 2 and then, yeah, sorry.
Yeah, every orbital can hold 2 electrons. It's all good. All good.
I didn't think it there.
D, what's the
double
shape?
peanut.
The double peanut. Right? I'm just placing those electrons anywhere. How many orbitals are in the D subshell?
5?
Uh-huh.
Look at us.
And how many electrons fit in the D subshell, sublevel? 10. Because if there's 2 in every orbital and there's 5 orbitals, that gives me 10 electrons. Okay, so F, what is my shape?
Flower.
Flower. 1, 2,
Could not
3.
draw.
1, 2, 3. And how many orbitals are in the F sublevel? 7. So how many electrons can fit?
14.
14. Yes. Yes. Perfect. All right. That is our review. Now we're gonna look at all of the notations. Okay.
Hold on, can you leave it up for 2 seconds?
Yeah.
I'm almost done.
Do you have all this though?
That's what I'm finishing.
Okay, that's all good.
I can't answer and write. That's my issue. So I was trying to answer the other
No, it's all
questions.
good.
I think I have it.
Chloe, just tell me when you're done, alright?
There it is. Let me get the SPDF thing though, because it's good to write down. And then
Did you get all this over here?
yes.
Okay.
Thank you.
Wow. It's so cute. Yeah,
Alright.
it's totally
So we're gonna do an example of all of these configurations and notations. And then we will kind of talk through things as we go that touch base on 5.2 and 5.3, okay? And I will post more examples if you guys want to practice these at home.
Yes.
But
please.
chapter review, you guys have tons already to practice. So if you want more, I mean, I'll post them.
Please
but
do. They help.
there's tons that are in the chapter review. Okay, we're gonna look at chlorine. Okay. So if you want, what page are you on, Chloe?
I'm on 106.
Okay.
cute.
How? I'm gonna ask you some
I
questions
had that too.
about chlorine. How many protons are in chlorine?
Oh,
17. Okay. Ellie, do you have your book? Okay.
I don't think so.
Will you share with someone? Because I would probably I would refer to this a lot in your, because we're just going to be going up and down a lot in this.
Okay.
Okay, chlorine. There are 17 electrons, right? What's the highest energy level of those electrons? How do you know?
Oh, I know this. Where'd it go? Where'd it go? Where's Chloe?
Group 17.
Oh, 7.
7, the highest. Oh, you're telling me valence electrons, right? You're telling me valence electrons. Ooh, you know a trick. Don't tell me the trick yet. Okay, so yes. 7 valence electrons. So, but the highest energy level. What's the highest energy level that we're in for chlorine? 1, 2, or 3? We're in energy level 3, right?
Oh,
because
that's
it's in
okay,
the third
sorry.
row. No, it's okay. We're in the third row. So our highest energy level is 3. Okay? So just so you guys know, the further you get away from the nucleus, the more energy those levels have. So 5 has a higher energy level than 2. 7 has a higher energy level than 6. Okay? It's kind of like when I was saying if you step up on a ladder, you've got more potential energy than if you're on ground level. Okay? So remember that. All right, so chlorine has 17 electrons. This is what a test question might look like. It might say, write the electron configuration for chlorine. That's it. So you have to look at the periodic table, see that it has 17 electrons, and then where do you start? Where do you go from there for electron configuration?
You do the arrows.
Mm-hmm.
What else?
Yep, we did a little arrows. And guys, okay, I told the other class this. So if you turn to the book that you're on, I minored in chemistry and here, let me get so that everyone on here can see too. And I taught this is my 4th year, and I just realized this. And it's so cool whenever you get to see how things in the periodic table fall into place, because it is really beautiful how God designed all of it to kind of fit together, okay? So energy level, sublevel S is over here, right? How many electrons fit into S? 2. 1, 2. What's P? P is over here, right? How many electrons fit into P?
Oh, 6.
6. 1, 2, 3, 4, 5, 6.
That's so cool.
It is really cool. I know, it's really cool. D. How many electrons fit into D? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then F is 14. And down below it's 14. There's 14. So it's really cool, like 14 rows. So it's just like all these little things where I'm like, oh, that's another little cheat. Oh, that's another little cheat. Like it all fits together in this really cool way. So I just realized that when I was doing these problems this week. So chlorine. So remember, basically I'm taking these electrons and I'm filling them up, right? So if you notice, right, hydrogen has 1 proton and 1 electron. If you go over here, helium has 2 protons, 2 electrons. You go down to lithium, it has 3, right? So basically, as you go down, all you're doing is adding a proton, adding an electron if they are neutral, right? That's it. So this whole thing is organized according to basically how many electrons they have and how many protons they have, okay? So that's why they all start with one S, because we're starting right here, okay? We're basically filling this shell, okay? So whenever you look at that diagonal, 1s, how many electrons fit into S?
2.
2. And there's like 1, 2, right? 2 electrons. What's the next one in that diagonal?
2s.
2s. Because, again, if I go down to my second energy level, look, there's only 2 here. There's 2 electrons, right, that can fit in there. 2s. And there's 2 electrons that can fit there. All right, guys, what is this right here? So if I said, what does the 1 represent in this? What does that 1 represent? The first energy level. What if I said, what does the S represent? It represents the S sublevel. Yes, the S sublevel. Yep. And if I say, what does that 2 represent?
Electrons.
The number of electrons in that single orbital. Yeah, exactly. Okay, so we've got 1s2, 2s2. If you go down the diagonals, what's next?
Is it 1p?
2p.
Was it?
2p.
I think so. I think it's 2p. Yeah. So if you go down, what page is that on?
108, next page.
Okay. So make sure you guys are following that. 2p. How many electrons fit into p?
6.
6.
What page are we?
Right? And if I'm following this right here, after I do 2s, guys, look, after I do 2s, this is where they get this diagonal from. After I go 2s, if I follow the second row, I'm in 2p. Okay, that's where they get this from. After I'm in 2s, if I follow it down, I'm in 2p.
Oh.
Okay, so I know we follow the diagonal. That's just kind of a cheat sheet, but there is a rhyme or a reason to why we do that. Okay, so 2p, 6. Then we're going to go, look, to the third level, right? And what is next in that diagonal?
3x.
3s. And how many electrons can fit in S again?
2.
2. And then what is after 3s?
3p.
3p. And how many electrons do we even have left? We've got 2, 4, 10, 11, 12. So how many go here?
5.
5. Does everybody know why I got 5? It's because basically I was counting up all of my electrons. Chlorine only has 17. I came up with 12. So P, even though it can hold 6, I'm only going to put 5, right?
Can you go over one more time how to find that, like those numbers specifically, like the 6 above the P?
Yep. It holds
So like
6
that.
electrons. P holds 6.
Oh, so you just write the number and how many it
Yep.
holds.
This is
Okay,
why I want
that's
you
where
guys to
got
memorize this
confused
so
on-
good. Yeah. Memorize it so good so that you guys can just start writing this out and you're like, oh, P holds 6, D holds 10, F holds 14. Okay?
That makes so much more. I'm so
Mhm.
lost.
Yep. So, this is electron configuration, okay? And you would know, because the book or the test will literally say, I want you to write this element's electron configuration. That's what you would write. Yes.
Do we get to look at the diagram?
For the test? Yeah, it's open book. Yep.
I love this.
Okay, so let's say I'm going to do noble gas notation. All right? The book, or not the book, the video I sent calls it abbreviated electron configuration. Okay? They say it slightly different. Okay? The video does. But the book calls it noble gas notation. Okay? And here's why. All right, all over here, group 18 in your periodic table. This whole group 18 are called the noble gases. Okay? The noble gases have 8 valence electrons. Okay? And we'll talk about valence electrons in a minute, but basically in their outer shell you can only have 8. Okay? So they are full. All right? They are full. They don't need any more. They actually don't do a lot of bonding because they're pretty happy the way they are. Noble gases, everybody would love to be nobility, right? So that's why throughout all this, you will hear me say they want to be a noble gas, right? So noble gas notation, I'm gonna look at this, okay? I'll tell you how to go straight to noble gas notation in a minute. But to go from chlorine, this electron configuration, to noble gas notation, I'm gonna look and see, I'm chlorine, right? This is chlorine. What energy level is chlorine in? 3. Chlorine is at energy level 3. So as I'm looking at this, the very first time I see 3, everything after that is chlorine, okay? This is all chlorine. Everything before that is going to be the prior noble gas, right? So if chlorine is number 17, right here, if I go up a level and to the right, what is my noble gas? Neon, right? If I go up a level and to the right. So this right here is neon. And if I want to double check myself, I can say how many electrons does neon have? 10. 6, 7, 8, 9, 10. Okay, so I'm going to put neon in brackets. And again, I know I'm going to start here because chlorine is in level 3. It's in energy level 3. So as I'm looking at this, as soon as I see my very first 3, it'll be 3s. Anything after that is going to be chlorine. Okay? Anything before that is my noble gas. So I'm going to put this noble gas, I'm just going to abbreviate that here. And then I'm going to write 3s2, 3p5. So if your thing said, write noble gas notation for chlorine, that would be your answer. Okay? Why do they do that? Why do you think? Does it look easier? Kind of.
Yeah, so your number isn't as like long.
Yeah, right? Because if we get to number like 117, and we have to write our electron configuration for 117 electrons, that's going to take a long time, right? So if you can find the noble gas that's right before it, again, you go up a level to the right, filled up all of those energy levels, right, for whatever that is, and then you're going to just fill in the rest of the electrons, okay? So we will start with a noble gas in just a minute, but I want to first get through how you do all of these first, okay? So what's this one up here called? This type of configuration is called what? Electron configuration. This one is called
Noble gas.
noble gas. Now we're going to look at orbital notation. Okay? The word orbital kind of tells me what this is, okay? Basically, I'm going to take my electron configuration and I'm going to draw orbits. Okay? That's where this information kind of helps a lot. I'm going to draw orbits. Okay? So I'm going to label this first orbital 1s, because remember, I'm in energy level 1, subshell S. How many orbitals does S have? Just 1. So that line, that dash, is going to represent that orbital. And remember, this is the number of electrons that are in it. And remember Pauli's exclusion principle? What does that say?
You fill up, or like you'll replace the
Opposite spins. Opposite spins, yes. So I'm going to put my 2 electrons here, guys. There's one. There's the other. Opposite spins.
Can you go
Okay.
that one time? Sorry.
Yep, it's okay. So I'm going to take my electron configuration and I'm basically going to turn it into orbitals. Okay? So I'm going to have my 1s orbital.
You always start with the 1s, right?
Yeah, for orbital notation, yes. I'm just going to be taking my electron configuration and turning it into almost like a diagram of what your electrons are doing, if that makes sense. So I'm going to take my 1s, it has 1 orbital, and I'm going to put, remember, according to Pauli's, there's an electron going one way and an electron going the other way. You can do full arrows. I just put half arrows because I'm lazy. That's it. So basically, but you do need to put one going one way, one going the other way. Okay? So what's my next one? 2s. So 2s, again, s only has 1 orbital. Can only hold 2 electrons per orbital, one going one way, one going the other, because there's the full 2 in there. Okay, my next one is going to be called 2p. right? Because I'm just going based on this. How many orbitals does P have? 3, right? Remember, if you remember this over here, like commit that to memory, it makes life so much easier. 1,
Oh, this makes so much
2,
more sense
3.
now.
Those are all the orbitals.
I want to go fix all my homework now.
So there's 6 electrons, right? I fill 1 in each first, just because that's what I've been trained to do because of Hund's principle, where every orbital gets an electron first before you go back and start doubling them. Okay, every orbital gets an electron that's going in the same spin before you start doubling them. And then my next one is 3s. And again, S has how many orbitals?
1.
Just 1. And there's the full 2 electrons there, right?
And it's always 2 arrows.
If there's 2 electrons in it, yeah. And there will always be unless you're at the very end, right? So yeah, because those represent the 2 electrons, because every orbital can hold 2 electrons. And then my very last is 3p. Okay, so this is going to be 3p. How many orbitals again are in p?
3.
3. So we've got 1, 2, 3. I've got 5 electrons, and so according to Hund's rule, I'm going to put 1 with the same spin in each first. So that's 1, 2, 3. Now I'm going to double. 4, 5. So one of those orbitals is not full, right? Because I only have 5 electrons.
And you always start with one going.
According to Hund's rule, you're going to give each orbital an electron going in the same spin before they start pairing up. That's why those principles are important whenever you start doing these. Okay, so this is orbital notation. Okay? Somebody asked before, like, how do I know which notation to do? They'll tell you. Okay, they'll tell you. They'll just say, hey, I want you to write this in orbital notation. Then you write it like this. Okay? They might give you one element, kind of like I'm doing chlorine, and say, I want you to give me the electron configuration, the noble gas notation, the orbital notation, and the electron dot notation for this. Okay?
You keep it for like 2 seconds.
Mm-hmm.
That makes so much more sense.
Okay, so one of the things that I briefly talked about was valence electrons. So the valence electrons are all the electrons found in the outermost energy level. Okay? Outermost energy level. They are only found in S and P. Okay? In S and P. That's it. Okay? And S can hold 2, P can hold 6. So the max number of valence electrons any element is going to have is 8. Okay? So if I look at this electron configuration, what is my highest energy level?
3.
3, right? So I'm going, all of my 3s, I'm going to look at how many electrons there are, and I'm going to add them up. 7. Yep, so chlorine has 7 valence electrons. Okay, so chlorine has 7, I'm just going to put a V like that, valence electrons. Is your brain hurting? Or is it okay?
No, I got
You
that.
guys are good? Okay, cool. All right, so then how does that translate to electron dot notation? Electron dot notation is just all about the valence electrons. Okay, so literally it is chlorine. You're going to put the element in the middle. Okay, and you're going to, your book talks about, really there's no rhyme or reason to where you put them, but I kind of think that there is. because later on we're going to be bonding, and so where you put them is kind of important. So I like to put them north, south, east, and west, okay? Don't be pretty and put here, 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 here. That's just, you can't do that, okay? Just put them north, south, east, and west, okay? So 7 valence electrons, we can't have more than 8. So what the book says is they put 2 first, right here. Why do you think they put 2 first right there? What do you think those 2 represent? The electrons for what?
S.
Yeah, S, right? Because valence electrons only occupy S and P. So they're saying that they're going to put 2 on one side first to represent S, and then because of Haughton's rule where they fill 1 per orbital, they're going to fill in the rest. So 2, 3, 4, 5, 6, 7. So this right here is electron dot notation. You guys, if you did this, I don't care. Okay? I don't care at all. If you did this, I don't care. Just have 7 dots around it for right now for me, okay? And I'll be happy.
That makes sense. Can we
Okay.
do another one of like all of these steps as an example?
Mm-hmm.
And then you always start on the left side.
You don't have to. You don't have to, but one thing that the book brought up, which I was going to touch base on Monday, but I'm just going to throw it out there right now because you guys already read it and probably already did some problems with it. Do you guys remember what an ion is? What's an ion?
It has different electrons and protons, right?
Yeah, it has a different number of electrons than protons, right? It is basically a charged atom. Okay? It either has
Oh, I remember that.
more electrons, all right, which makes it what? Positive or negative? It has more electrons.
Negative.
Negative, right? Because an electron is negative. So if I have more negative, I'm going to be negative, right? Because I'm going to have a net amount more of electrons than protons. So do you guys remember what is a negative ion called? The book named it for you. Do you guys remember?
It's like on the tip of my tongue. I can like see where it is. Hold on.
It's an anion.
That
It's
is
an anion. Mm-hmm.
not-
Do any of you guys take like a Latin or Greek or anything like that? No. An usually means like the withdrawal of or lack of. So it's basically saying this is a negative. Okay, it's got a negative charge. Okay. A positive ion. Do you guys remember what that one was called? It's called a cation. Somebody in my last class drew like a cat's eye to remember that.
That's
So
hers.
it's just cation. It's a
Oh, with the
positive.
plus. That's smart.
Yeah,
I'm gonna
with the
copy
plus
that.
sign in it. If that helps you remember what those are. So if for some reason this chlorine had an extra electron, right? I'm going to color it blue so that you realize it's not one of the valence electrons. Again, is it going to have a positive or a negative charge?
Negative.
Negative, right? Because I added an electron. So if that was the case on electron dot notation, I'm going to put brackets around it and then I'm going to write the charge above it.
Wait, how would it have an extra?
Because sometimes it will take electrons. And so we'll learn about why it takes them or gives them away later on, but you don't need to know that. Just know that if it has an extra one, that's what it looks like because I think this is in 5-3, and so it will be on the test. And if it has one that it gave up, I'll show you what that looks like too, okay?
Will you be able to like tell which one's the extra?
They will tell you, no, not like tell which one's electrons. They'll just say like, if chlorine gained an electron, what would the electron dot notation look like? That might be what the question would ask. If electron gained an electron, what would that electron dot notation look like? Okay? And remember, it's not going to gain more than a total of 8 valence electrons. So chlorine can't have more than that. Okay? Alright,
And
let's
what do you
run
put in the top right again? Sorry.
the charge. And negative, if I don't put a 1, it's going to be, it's assumed, if it's just a charge, it's assuming that it's a 1. Okay, let's go through one more of these. I'll probably run through it pretty quickly since we only have like 10 minutes. Let's see. Let's do... Okay, sodium. And I'm not going to give you guys an element that has like 54 electrons, okay? I'm going to give you something reasonable. Okay, guys, what's the atomic number of sodium? 11. Okay, so that means that I'm working with 11 electrons, right? So somebody tell me electron configuration. What am I going to write here?
S1.
What is it? 1s what? 2. Because 1s is my first, it can hold 2 electrons. Next? 2s, 2. Next? 2p. 6. Next? 3s what?
2.
No.
Oh, what?
1. Why is it just 1?
Because you're already at 10 electrons.
Yes. So I'm already at 10 electrons, Kaylee, that's why. Because I've got 6, 7, 8, 9, 10. I've only got 1 more to fill in. Okay? Okay, so I'm just going to jump into orbital notation because it's kind of easy because I've already got it here. So orbital notation, I've got 1s. There's 2 electrons in there, right? 2s, I'm only drawing 1 line because I've only got 1 orbital in s. 2p, how many orbitals am I going to draw? 3. Because remember I have 3 orbitals, that's why I can fit 6 electrons. Okay, and they're all filled up because there's 6. And then my next one?
1.
3s, yes, and I'm just going to put 1 electron in there.
Can I take a picture?
I was with it too.
Yep, so that is orbital notation. Noble gas notation. What's my noble gas that I'm going to do for sodium? What is it? Can't see. I'm sorry. It's okay. No, it's good. Okay, cool. Neon. Right? So where am I going to, what is neon? What am I going to start with?
Brackets. Oh, wait. The 2s?
Yeah,
everything
all
with
of
the
this
2.
is neon.
Yeah.
All of this is neon. And I know because sodium starts on 3, energy level 3, right? Isn't that the first hydrogen, lithium, sodium? Is it right there? So 3, it starts on 3. So this right here is going to be my sodium. This right here is going to be my, was it neon?
Yes.
So I've got neon, which is represented by all of this. And then I'm just going to bring this down. 3s1.
Oh, it's so nice looking.
How did I not know it was a
I know.
It's pretty.
Okay, so again, let's go through electron dot notation. Based on this right here, how many valence electrons does sodium have? We're going to look at the highest energy level.
1.
Yeah, the highest energy level is 3, right? And I've only got 1 orbital in that highest energy level. It's the S, and there's only 1 electron. So sodium has 1 valence electron. Okay? So writing that, I'm going to put...
dot.
Yep, I'm just going to put a dot. You can put it really anywhere you want. Just put a dot. Yep. That's sodium.
Okay, yeah, let me take you to this too. Because writing is not helping.
You guys will learn this later, but here, maybe I'll make it darker so you can see for sure. You guys will learn this later, but sodium, anything in group 1, they're going to get rid of that electron very, very quickly, okay? Think of it as like they've got a very loose grasp on it. It's pretty far away. It's only 1. They're going to get rid of it very quickly. So sodium, you will see it written like, so if they said Suppose sodium took an electron away. What kind of ion is it going to be? An anion or a cation? Let's say they took this electron away. It'd be a cation, right? Because you're taking away a negative, right? So if I took away this electron, that would be the electron dot notation. There's no dots left, right?
One more.
And I would just write it like that. Okay. Huh?
Right.
It went away.
Oh,
We'll learn
the
where it
dot.
goes later, but it loses it very easily. So you could say, well, why don't I take those 8 and fill it?
Wait, is this not even in the book? I feel like I've read about that.
The ions are. I don't know if they did sodium or not. They might have done
No,
sodium.
about them like
or something.
going away. Hold on. I feel like I've written something.
They
about
they give it away. Group 1 gives away those electrons really easily. They're kind of loose.
Yeah.
And then group 17, they want them. They've got 7. They want that last one so bad. So actually, group 17 takes from group 1 really, really frequently. So anyways, so that's it. Okay, guys. Bring any questions you have on Monday. Today I will post extra practice if you want to practice them. I will also post what's going to be on the test, so you guys can start kind of looking at that too.
It's on Wednesday.
Wednesday. Yep, just bring your finished work on Monday.
Do we have a lot of homework after next Thursday?